There's a ton of those out there because that's what they say happens. That's one of the ways they explain mirages. And so and then you go, okay, and you're saying all the light bends down, but we have evidence that it goes up. So what happens when it's not going down or not going up? Do we see the geometric horizon then?
Yeah, it's...
They have serious problems. Like, we would be able to detect the geometric horizon when the light would be normal or not going up or not going down, but we don't see the geometric horizon. And then when we use infrared, which is supposed to make the refraction less, so the horizon should always move closer if it's always refracting down, but that's not what happens. We see even further, so it's the opposite of what would happen if the Earth was a globe and the light was bending around it.
Yeah, exactly, because they'll quite often agree, right? If before you ask them the question about removing the atmosphere, would you see the horizon where it should be? They'll say, if before you ask them that, you ask them, can you see further on clearer days? They'll always say yes.
Yeah, I think it's good to kind of almost like trap them into those things in the beginning and then go into it, because that way it's harder to just like turn around and just imagine nothing happened, because you kind of already admitted it.
Yep.
When they admit it, when they admit that refraction, more refraction make you see the longer distance, but less refraction, you will see a shorter distance to the horizon. I just use at those moments the videos and the observations with the infrared by minimizing the refraction effect on those infrared and that infrared spectrum. So if we minimize the refraction effect using an infrared filter or lens, camera or telescope, so we should see shorter distance, but we don't.
We see the opposite.
We
see longer distance, exactly. I've never seen a single observation where the geometric horizon is anywhere close to where it should be.
Did you see that one that Jay Tolan made with the thermal camera?
Yeah, I've seen it, but I haven't looked deeply into that one because of the altitude and you know, the elevation and stuff, changes of the land below it. I just haven't looked into that one enough. Yeah. I need to. I don't understand enough about infrared to say it cuts out refraction. So how much does it cut out? I think the best thing to do would actually be to go to a place where you have a body of water and you have the water temperature is the same temperature as the air above the water. Because atmospheric refraction, they say it's the change in the refractive index, which is caused by having a warmer or cooler layer of air closer to the surface and then gradually warming or cooling as you go up in altitude. And that's what causes the different types of miraging effects. So if you don't have the difference in the water temperature creating that different temperature just above the surface, then you shouldn't technically have that atmospheric refractive index change. So you should see close to what it should be.
Yeah, it's how steep the gradient is. If there's a big difference in temperatures, and the bigger the temperature difference, the harder the gradient, if you will. Like it's bigger and has more effect, and becomes almost like a band, if you will. That's one of the reasons when you're looking out and you see like miraging effects in the air, or like all these towering effects where you see the stretching out, like for instance in the black swan image. That's where there's a gradient in the air, because oftentimes there's an inversion, or like hot air is coming underneath, or cold air is coming underneath the hot air, and so when these inversions happens, you get these boundaries between them where they're diffusing into each other, and equalizing, and so that's where the gradients happen.
Yeah,
But
completely agree.
Drace, my problem is not with the gradient like you're explaining it, but how that gradient will be just horizontally. I can understand it. Yeah, being vertical. So
Yeah, no,
that's
yeah.
like that's
They try to invoke. Yeah, I know what you mean. They try to invoke the pressure gradient, but that's not what anybody's talking about. This is winds and the motion of hot and cold air as it moves against each other, and like the whole air is dynamic. So like each wind wave that hits you is a pressure wave. Like they imagine this idealized like pressure gradient going all the way up and down, but it's not like that. It's chaotic. It's inhomogeneous, anisotropic.
They imagine that a gradient that is vertical to the sky.
Yeah, the Globers like to do that because they invoke gravity, but that's just not
But it
realistic
doesn't
conditions.
work. But it doesn't work on their favor because
Yeah, I know.
for their claimed refraction, even if we don't use the Snell's law, we use that refraction that they claim that is because of the density. So the light goes from less dense medium to a denser medium, and it slows down, so it changes its path. No, going to the sky, light going from an object to the sky, it's going from a denser medium to a less dense medium. So it's not slowing down, but it will speed up. So it will not refract down.
Yeah, it starts getting very complicated when you're trying to work out exactly what's going on with the densities, because you have the optical densities, the main thing that they say is the cause of the atmospheric refraction effects.
Necros is also really right in that one of the things they do to try to mess with this, to try to invoke the ball, is depending on which way they imagine the gradient, they move the starting point from either their eye or the other location. So, like, in order to make it always bend down, if the gradient is inverted and the starting point of the laser or light would cause the light to go upwards, they simply imagine the light coming from their eye to the object and bend it down.
Yeah, that's what they think. That they change the vector so the light is not coming to their eyes, but it's going from their eyes, like Superman.
I heard Drace was back on the circuit. Good to hear from you, brother Drace.
Hey.